Good day, students. This is me again, your teacher in Statistics and Probability. And for today's lesson, you will learn about understanding hypothesis testing. This topic is the very first topic for quarter 4. So be with me as I discuss to you what this lesson is all about. What is hypothesis testing? Well, hypothesis testing is a decision-making process for evaluating claims about a population based on the characteristics of a sample purportedly coming from that population. The decision is to whether the characteristic is acceptable or not. So basically, one thing that you remember about hypothesis testing is that it is a decision-making process about claims for a certain population. And since population is very big, it takes a lot of time to measure the entire population due to its large sample size. Then we can use off-sampling. That's why we get samples. The decision for the characteristics of a sample coming from that population is to whether it is accepted or not. So in hypothesis testing, you will be making this decision. In hypothesis testing, there are two types of hypotheses. The first one is the null hypothesis, and this is its symbol. Well, based on readings, this is read as H0, or for null hypothesis, just remember there seems like 0 or O, so that is a symbol for null hypothesis. Null hypothesis is a statement that there is no difference between a population parameter, mean or proportion, and a specific value, or between two parameters. So for null hypothesis, there is equality between two parameters. So since there is equality, then there is no difference between these two measures. The second type of hypothesis is the alternative hypothesis, and in symbol that is H sub 1. So for null hypothesis, that is H sub O or H sub 0, while for alternative hypothesis, that is H sub 1. Alternative hypothesis is a statement that there is a difference between a parameter and a specific value, or between two parameters. So one thing that you should remember between the two hypotheses is that for null hypothesis, there is no difference between the two, or the two measures are equal. But for alternative hypothesis, there is a difference between two values. The other could be greater than the other value. You can also identify whether the given is a null or alternative hypothesis depending on the symbols used. So basically, tests could be non-directional test or two-tailed test, and the other one is directional test or a one-tailed test. For null hypothesis and alternative hypothesis, there is a corresponding symbol for a particular type of test. So under the non-directional test or the two-tailed test, for null hypothesis, you will just use equal since the two parameter values are equal. There is no difference. But for alternative hypothesis, you use the symbol not equal to, since for alternative hypothesis, there is a difference between a parameter and a specific value. For directional test or one-tailed test, this is the symbol used. For null hypothesis, you use the symbol greater than or equal to, or less than or equal to. Take note that for null hypothesis, there is a symbolism of equality. That's why we denote here or we place here the equal to symbol. But for the alternative hypothesis, you use greater than for right-tailed test and less than for left-tailed test. So take note of these symbols because this will guide you to identify whether the given hypothesis is null or alternative. So in this table, you will see the difference with regards to the symbols used for alternative and null hypothesis in non-directional two-tailed test, left-tailed test for one-tailed, and right-tailed test, still it's a one-tailed test. Let's have this one. Example, mu or the population mean is not equal to 10. So this is for alternative hypothesis under non-directional two-tailed test. But for its null hypothesis, population mean or mu is equal to 10. So as you can see, for the null hypothesis, it suggests equality. And for alternative hypothesis, they are not equal. So there is a difference. And since it's two-tailed test, we do not know the direction. Just use the symbol not equal to. For left-tailed test, since this is one-tailed, its alternative hypothesis is less than. So the population mean is less than 20. While its null hypothesis, since again null hypothesis denotes equality, we use the symbol population mean is greater than or equal to 20. For right-tailed test, still it belongs to one-tailed test, population mean is greater than 15. So we use the symbol greater than and it is right-tailed. For its null hypothesis, we use the symbol population mean or mu is less than or equal to 15. So take note that the symbols used for non-directional tests in alternative and null hypothesis are opposites. So if you use equal for null, its symbol for the alternative hypothesis is not equal to. For left-tailed test, if its alternative hypothesis is less than, then its null hypothesis is greater than or equal to. For a right-tailed test, you use the symbol greater than, and under the null hypothesis, you use the symbol less than or equal to. If you have observed, the symbols for alternative hypothesis is the opposite for its null hypothesis. So another element in hypothesis testing is what we call significant levels. So significant levels is symbolized in this Greek letter alpha. Now, since they are common, there are actually many significant levels. It depends on the study. But since we are talking here about common, so these are the commonly used significant levels. We have 0.10, 0.05, and 0.01. In every significant levels, there is also its corresponding confidence levels. So for 0.10, its confidence level is 90%. For 0.05, the confidence level is 95%. And for 0.01, the confidence level is, what do you think? That is right, it is 99%. If you have observed, when you add 0.10 to 90%, 0.05 to 95, 0.01 to 99, its sum is 100%. Another important element in hypothesis testing is what we call the rejection region, also called as the critical region. This refers to the area where the value of the test statistic lies for which we will reject the null hypothesis. It may be on the left or right or both, depending on the alternative hypothesis. So for two-tailed test, these shaded regions are the rejection region. The unshaded portion is the acceptance region or the non-rejection region. When your computed value or computed statistic lies on the shaded portion, then you reject the null hypothesis. But if it's within the non-rejection region, then you do not reject the null hypothesis. For left-tailed test, you can see the rejection region shaded on the left portion. While for the right-tailed test, the rejection region is found on the right portion. So remember, the unshaded portions are the non-rejection region, while the shaded portions are the rejection region, also called as critical region. Actually, there are keywords that will suggest whether the given hypothesis is left-tailed, right-tailed, or two-tailed test. If the alternative hypothesis makes use of less than or any other synonymous words like decrease, smaller, below, to the left, etc., it suggests a directional left tail test, meaning the rejection region is on the left tail of the normal curve. If the alternative hypothesis makes use of greater than or any other synonymous words like increase, larger, above, to the right, etc., it suggests a directional right tail test, meaning the rejection region is on the right tail of the normal curve. If the alternative hypothesis makes use of not equal to, it suggests a non-directional test also called two-tail, meaning the rejection region is on both the left tail and the right tail of the normal curve. So my dear students, you just have to take note of the words being used because it will give you a hint whether the given hypothesis is a directional test or a non-directional test. In this activity, you formulate the alternative hypothesis and its null hypothesis, and then you identify the significance level and identify as well the rejection region for each of the following. So you write them in symbols. This is our first problem. A researcher claims at 95% confidence that the average TV viewing time of all 5-year-old children is more than 4 hours daily. Again, a researcher claims at 95% confidence that the average TV viewing time of all 5-year-old children is more than 4 hours daily. For the alternative hypothesis, the average TV viewing time is more than 4 hours daily. In symbols, we have H1 is population mean is greater than 4. This is stated in the claim. As you can see, the words more than is highlighted. It's in bold and it's even underlined. For the null hypothesis, the average TV viewing time is less than or equal to 4 hours daily. In symbols, that is H0 is population mean or mu is less than or equal to 4. So the symbol less than or equal to is the opposite of the alternative hypothesis. Significance level at 0.05 because the confidence level is 95% as stated in the problem. The rejection region is right-tailed as evidenced by the alternative hypothesis, population mean is greater than 4. So let us proceed to the second problem. A college librarian claims that an average of 20 storybooks are borrowed daily. At 99% confidence level, test the claim. So again, a college librarian claims that an average of 20 storybooks are borrowed daily. At 99% confidence level, test the claim. So in this problem, the alternative hypothesis is the average number of storybooks borrowed daily is not 20. For H1 is mu is equal to 20. Now, you may wonder why did we use not equal to? It's because the claim has no direction. It simply states in the problem that there is an average of 20 storybooks borrowed daily. And that is why you just use not equal to. For the null hypothesis, the average number of storybooks borrowed daily is 20, or in symbols, that is H0 is population mean or mu is equal to 20. So again, it is the opposite of the alternative hypothesis. So significance level at 0.01 because the confidence level is 99% as stated in the problem. While the rejection region is two-tailed, it's because this is evidenced in the alternative hypothesis. H1 is that mu is equal to 20. And that is all about for our first lesson, understanding hypothesis testing. I hope that you learned something from this video, and I hope this video tutorial as well help you in answering your activity. So you can now proceed, and if you have questions, feel free to ask me. Goodbye and have a great day.